Hi everybody, today we'll learn how to convert a binary number to a decimal number and a decimal number to a binary number. And to briefly mention what binary is or what binary numeral system is, binary numeral system or base 2 numeral system is a numeral system that uses only two numbers, 0 and 1. These numbers are called binary digits or bits, and in computing, a bit is the smallest unit of data or information. There are different analogies for these two numbers, where 0 can represent that something is off or false, and 1 can represent that something is on or true. Now let's begin with what you guys came here for, to learn how to convert a binary number to a decimal number and vice versa. So let's begin with converting the binary number or the octet we see on the screen to a decimal number. Now, if you're not sure why I called the binary number octet, that's because an octet consists of 8 bits. And if we counted the bits in the binary number we see on the screen, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 bits here. So the binary number on the screen consists of 8 bits. Another term that you might be more familiar with that we can also use for a group of 8 bits, like the binary number we see on the screen, is byte. Now, to help us with the conversion of our binary number, we're going to use the power of 2 table, which looks something like this. Here we have a power of 2 table that consists of 8 columns, where each column has a different number. Each number is a result of a base number and its exponent. The exponent tells us how many times to multiply the base number by itself. So let's say that the base number is 16, for example, and the exponent is 5. That means that we need to multiply 16 by itself 5 times. So we raise the base number to the power of another number and we get each number that we see in our table. And what is the base number going to be in our table? Let me give you a couple of hints. So our binary number that we want to convert to a decimal number comes from a base 2 numeral system. And to help us convert that number into a decimal number, we're going to use the power of 2 table. So if you guessed that the base number is 2, you are correct. So let's create our power of 2 table from scratch. We begin from right to left. So the base number is 2, the exponent will be 0. And any number to the power of 0 is 1. So 2 to the power of 0 is 1. So we place 1 in the first column from the right. Next, the base number will of course remain the same, but we're going to increment the exponent by 1. And any number to the power of 1 will be equal to the base number. So in our case, 2. So 2 to the power of 1 is 2. So we place 2 in the second column from the right. Next, again, we only increment the exponent by 1. So 2 to the power of 2 is 4, and we place 4 in the third column from the right. And we continue like this until we've reached the final number in our table, 128, which is the result of 2 to the power of 7. The reason we stop at 8 numbers in our table is because our binary number is 8 bits. And what we are going to do with our binary number is place it above the numbers in our power of 2 table, where we take each bit in our binary number and align it, if I can put it this way, with each number in our power of 2 table, like this. If, of course, our binary number consisted of more bits, we would then have to expand our power of 2 table accordingly by continuing with 2 to the power of 8, 2 to the power of 9, etc., depending on how many bits the binary number we wish to convert to a decimal number consists of. But today, our binary number consists of 8 bits, so our power of 2 table will only consist of the 8 numbers we see on the screen. What we need to do next is take only the numbers from our power of 2 table that are aligned with the binary digit 1 from our binary number and write it down. In our case, we are going to write down 128, 64, 8, and 2. Then we need to add those numbers together. And what we get when we add those numbers together is our binary number in decimal. which is 202. Now let's do the opposite. Let's convert a decimal number to a binary number. So let's convert the decimal number 202 back to a binary number. So in the way that I'm going to show you how to convert a decimal number to a binary number, we're going to do some dividing. Since we are converting a decimal number to a binary number, so to a number from the binary numeral system or base 2 numeral system, when we divide, we are going to use 2 as our divisor. So let's begin. We take the decimal number that we wish to convert to a binary number, in our case 202, and divide it by 2. The result is 101, so there's no remainder here. That's why we can write down 0 as a remainder. And let's write down our remainders from right to left. Next, let's divide 101 by 2. The result is 50.5. So the remainder here is 1. That's why we can write down 1 as a remainder. Now, if you're confused on how we get 1 as a remainder, here is the math to understand how we got a remainder of 1. So we take 50 without the 0.5 and multiply it by 2, and we get 100. Then we take 101, our dividend, minus 100, and we get our remainder, which is 1. And I'll place the math of how we get a 1 as a remainder each time we divide a number and get a remainder of 1. So next we divide 50, not 50.5, by 2. The result is 25, so there's no remainder here. That's why we can write down 0 as a remainder. Next we divide 25 by 2. The result is 12.5, so the remainder here is 1, so we can write down 1 as a remainder. Then we divide 12, not 12.5, by 2. The result is 6, so there's no remainder here. That's why we can write down 0 as a remainder. Next, we divide 6 by 2. The result is 3, so again, there's no remainder here. That's why we can write down 0 as a remainder. Then we divide 3 by 2. The result is 1.5, so the remainder here is 1. So we can write down 1 as a remainder. Then we divide 1, not 1.5, by 2. The result is 0.5, so the remainder here is 1. That's why we can write down 1 as a remainder. And now, since our quotient reached 0, we can stop here. And what we see from what we've written down is our decimal number converted to a binary number. So this is it for today, guys. I hope you found the video helpful. If you did, I would really appreciate it if you gave the video a thumbs up. And of course, subscribe to the channel if you haven't done that already. So that's it for today, guys. I'll talk to you next time.